All right, perfect. So this is going to be about boto3, which is the SDK for Amazon's API in Python. The SDKs are generally just called the AWS SDK in all the other languages. In Python, it was an open source project before Amazon took it over, so it has an old name, but it's just a wrapper around AWS's live API in the cloud for the Python programming language. Like all APIs, it can, or many anyways, it'll return lists of things, and sometimes those lists are long. And the old school way to handle that was paginators. We'll look at that first. And then there's a newer way, which I think is simpler, called collections. So, oops. So that, sorry, missed a slide. I'm going to use an S3 bucket for the example. This is a live one. It's maintained by Amazon. It just has some example stuff for CloudFormation. It doesn't really matter what's in there. It just, we need a bucket that has some files in it so we can demonstrate this. This only has 5 objects in it, which isn't really enough to need pagination in the first place, but I wanted something that would fit on the screen. So we'll just kind of simulate from there. Because it only has 5 objects in it, technically we don't have to paginate. And so the simplest way to get the objects in the bucket in the SDK, you just instantiate a client object wrapped around S3. You have to know that you need this list objects v2 method. There was a v1 that was just called list objects. Now there's a v2, you just have to know that. We'll get to how collections make that simpler in a minute. You tell it what the bucket name is, call that method, and then you get back a response object. You can loop through it, get the objects out of it, pull their name. So this prints out the same 5 objects as that CLI command does. It doesn't have like the timestamps and stuff on it because I kept the code simple. It just pulls the key name. You could get all the stuff that the CLI gets out of it if you wanted to. The main problem is that this only works for up to 1,000 objects in the bucket. If you have more than that, you just don't get them all back. You can kind of simulate that even though this bucket doesn't have very much in it. Really, 1,000 is the max value of this max keys parameter. It's also default. So if you drop it down, you see it just doesn't return all the stuff. We need something that will work no matter how many objects are in the bucket. And I've actually seen a ton of code, especially in DevOps, like glue code that hooks stuff together that doesn't paginate. And then the system number of objects in there grows beyond 1,000. And all of a sudden you get really weird bugs because it just doesn't return everything. So we need a system that will work for arbitrary numbers, as many as the bucket could hold. The old school way to do that was pagination. You still get a client object. We're still going to use the list objects v2 API, but now we're going to use that with this get paginator thing, which returns a paginator object. We can call the paginate method. And now we get back, instead of just a list of objects, we get back a list of pages. Each page has objects on it. And we'll just keep getting more and more pages. And we can loop through the objects on that page until we get everything in the bucket. That's how it handles really large return lists. So this function has the same output as the previous one. It gets all the stuff in the bucket, but it'll work no matter how many things are in the bucket. It'll work for as many as S3 supports. What I don't like about this method, and the reason I try to use collections instead, is that I have to know details about what APIs are available and how they work. I have to know that I need this v2 of list objects, not the original one. And I have to know that I'm going to get back pages of objects, so I need this nested loop to go through it. That's not a huge deal, but it's kind of annoying, and I often forget it, and I end up going back to the docs to hunt out the right way to do it. There's a newer thing that Boto has called a collection. To use it, instead of instantiating a client, we get a resource. And what the resource lets us do is instantiate a bucket object using the name of the bucket. So now we have a Python object, which represents the object, the bucket object in the Amazon cloud that's live. Once we have that representative object, we can just tell it, hey, I want all the objects that you have. These would be objects in S3. And then it'll give us back an iterable, and we can just go through that and one at a time and get all the stuff out of it. So this produces the same list of 5 objects as before, but I didn't need to know about list objects v2. I didn't have to deal with there being a bunch of pages that each have objects on. I don't need a nested loop. I just create a bucket object, tell it I want the objects in that bucket. You can also do filtering. You don't have to just get everything. You can tell it, just give me ones that have a certain prefix. The prefix is the only filter you can do right now, but it's pretty powerful. In S3, it's technically a flat structure, and so it simulates having folders or directories by using a convention of forward slashes and prefixes in the name. So you can essentially use this to limit your filter down to directories, even though those aren't really a thing, or something analogous to directories in S3. And that's about it. Like, once you know how to do this, you can use collections anywhere you want or anywhere they're supported. there are a couple things to know. I think I saw this in the chat. If these look familiar from Django, that's by design. This is in the docs. They were intended to look like query sets in Django's ORM. They're meant to give you an interface to objects in Amazon's web services that looks familiar to somebody who's worked with a web framework that's wrapped around a database. They're not available for every resource type. So they have them for S3, I think EC2 and a couple others, but definitely sometimes like you have to go to the Boto docs for whatever Amazon service you're using and check and make sure that it has collections in there. If it doesn't, you have to fall back to paginators. They're chainable, so you can like there's a limit function that I didn't really cover because it's not super necessary, but like you can filter on a prefix and then you can limit just to some replies and stuff. So you can filter them similar to how you would in Django's ORM, but also similar to that, you gotta be careful about performance. They can generate a lot of API calls. Just like the web framework it's gonna generate some SQL behind the scenes to try to dig everything out of the database for you. And hopefully it will do that efficiently, but maybe it doesn't. Something similar is going to happen here. Behind the scenes, it's going to automatically come up with some API calls to try to pull all these objects out of Amazon, but it may or may not do that in an efficient way. I've never actually had this become a problem, but it can happen. So if you're using collections and you start to get weird performance behavior, you might need to fall back to paginators and do some of your own optimization. Hopefully you won't run into that. I never have, but it is worth pointing out. And that's all I got. You're welcome to hit me up if you have questions. There's also a link here. I have some of this code is copy pastable up on my website if you want to play around with some examples.